Welcome to another episode of Comet Algebra. These are the notes for 10.5, graphing sine and cosine. Now, trig functions model motions in the real world that have a cycle, a repeating cycle of things, like the example your book gives is a wave pool. And we need to learn how to graph them, which really isn't very difficult because your graphing calcs can help. Couple definitions. First of all, the period of the function is, I like to think of it as the horizontal repeat. When does the pattern get back to where you started and repeat itself? And that's measured horizontally. And so you can see in the x and y axis I've drawn, the x-axis is marked off in pi's. So that's what we'll measure the period of the function in. Amplitude is simply half the height. How tall is it from top to bottom? And the amplitude is that height. So the first example we're going to do is graphing the sine of theta. I believe this is your problem 1 in your assignment. Now, a couple things to get your calc set up. First of all, your calc will not recognize a different variable. If you type in y equals sine theta, it won't know what you want. Your calc graphs in x's and y's, so you will need to enter in the y equals key sine of x. Next thing, I need to give credit to Sierra for telling me about this. To get your calc to graph the way we have it set up here in radians with, this first radian measure, this pi over 2, this is equal to 90, the pi is 180, 270, and then 2 pi is 360. And it would be ideal if our calc could match this for us. So in your window settings, if you set your x min and max, we want to go pretty wide. So let's go from negative 500 to 500 for our min and max. And then if you hit your x scale and you scale this at 90, it's going to set up these exact spacings that we have set up in radians. So thank you, Sierra. That was awesome. So after you have that entered, sine of x, and you hit graph, you can jump back and forth between the table and the graph to do this accurately. So if you look, what is the sine of 0? 0 degrees is 0. The sine of 90 is 1. So we have that point. The sine of 180 is back to 0. Sine of 270 is down at negative 1. And then the sine of 360, we're back up here at 0. Likewise, if we go backwards into negative land, the sine of negative 90 is negative 1. Sine of negative 180 is 0. And so on. So now if we're ready to connect our dots and graph this beautiful sine wave, it would look something like this. Now it's going to be very handy for you to keep this, we call this the parent equation, on your calculator. And then when you have to graph, I can't remember what your homework has, maybe 3 times the sine of x. Leave this parent in y1 and go down to y2 and graph the next one, and then you'll be able to see what changes have been made. All right, let's look at period and amplitude. Period is where this repeats. So, and try to find a section I drew kind of accurately because this isn't so good. This is supposed to be coming through 0, as you know. So if I was going to find the repeat and I wanted to visually start right here at the origin, so when is this going to be going up again in the pattern? So it's going up and then down, and right here we're back to the x-axis and we're going up again. So if you were to cut this piece out in between these two blue lines and pick it up, that pattern repeats itself right here, and it would keep going. So the horizontal length of this repeat, it goes from 0 to 2 pi, so the period is 2 pi. Amplitude is half the height. We're up here at +1, we're down here at -1, so it has a total height of 2 units. Half that height is 1. Let's look at the graph of cosine next, and I believe this is number 2 on your homework assignment. So once again, enter y = cosine x, and leave your settings here so that it's graphing with your x-axis at every 90 degrees, or pi/2, pi, 3pi/2, and 2pi. And you can either look to the table, or you could put on your calc what is the cosine of 0. Cosine of 0 is 1, so that's where we're going to start. Cosine of 90 is 0. Cosine of 180 is down here at -1. Cosine of 270, back at 0. Cosine of 180 is at 1 again. Going backwards, the pattern repeats itself. Connecting your dots. See if I can do a better job with the wave this time. Now, a possible question that I've heard about on the ACT is they'll give you 2 graphs and they'll say, identify which one of these is sine and which one is cosine. And if you'll notice, a sine wave at 0, cosine is 1. So the cosine will cross at +1. And if you look at your sine wave, the sine of 0 degrees is 0. So a sine curve wave will always cross the origin. So that's a quick, easy way that I use to identify quickly if it's a sine or cosine. All right, let's do the period and amplitude. Again, period is the horizontal repeat. So if you want to look at, let's just look at it differently instead of starting at the origin, because we can't always do that. Let's have our eyes look from this point. So we're down at the lowest point, following the curve up, following the curve down. We're back here at the lowest point. So that's, and if I could draw a straight line. So that's a repeat. That's the period. But it may be a little tougher to judge the distance. Well, if we're at 0 here when we go -pi, and here we go 0 to +pi, the distance of the repeat pattern is 2pi. And once again, high to low, we're here at 1 to -1, total height of 2. So the amplitude for the cosine curve is also 1. All right, that's it. Have fun graphing sine and cosine.